Right now, at this very moment, some of the world's greatest scientists, Nobel Prize winners, professors at MIT, Harvard, Johns Hopkins, are sitting in front of data from the James Webb Space Telescope, and they are quietly, privately, terrified. Not because of what they expected to find, but because of what they did not. Because the universe they see through Webb's golden eye does not match the universe in any textbook ever written. It does not match any simulation ever run on any supercomputer on Earth. Galaxies that should not exist are everywhere. A monster spiral galaxy, 10 times larger than the Milky Way, was spotted forming stars 300 times faster than our galaxy, completely calm, in a cosmic era when everything should have been chaos. The most distant object ever seen by humanity was confirmed in 2025, just 280 million years after the Big Bang, and it contains chemistry that should have taken billions of years to develop. And on top of all of this, the mysterious dark energy, the force Einstein believed was constant, the invisible engine of the entire universe, is now showing signs of weakening. If you are not yet alarmed, stay with me. Because the universe is not what we thought it was. And James Webb is the telescope that is proving it, one discovery at a time. Let us start with the discovery that shook galaxy science to its core, published in Nature on May 21, 2025, by a research team led by Dr. Shuo Huang at the National Astronomical Observatory of Japan. Using a combination of the James Webb Space Telescope and the ALMA Radio Observatory in Chile, scientists turned their instruments toward a galaxy in the constellation Cetus, a galaxy called J0107a, and what they found defied every simulation of the early universe ever created. J0107a is an exceptionally massive example of a monster galaxy, with a mass more than 10 times that of the Milky Way and a star formation rate approximately 300 times that of the Milky Way. Even more surprisingly, J0107a has a perfect barred spiral structure, one of the largest and most distinct of any galaxy in this cosmic epoch. ALMA Observatory. This galaxy exists 11.1 billion years ago, when the universe was barely 2.6 billion years old. At that time, according to every cosmological model ever built, galaxies were supposed to be small, messy, turbulent structures still crashing into each other and gradually assembling themselves through violent mergers. In the early universe, galaxies were supposed to be messy. They were expected to grow by merging with other galaxies. Those collisions usually leave galaxies looking distorted and irregular. But J0107a doesn't show signs of a recent merger. Its shape is smooth and symmetric. Its motion is calm and ordered. DIY photography, something extraordinary, something our models never predicted, built this perfect structure in the chaos of the early universe. Here is why J0107a is so genuinely alarming for science. The bar structure at the center of a spiral galaxy, that straight line of stars and gas cutting through the center, is not just a cosmetic feature. It is a mechanism. It acts like a cosmic pump, funneling gas toward the galactic core and triggering enormous bursts of star formation. Our own Milky Way has one. But our bar took billions of years to develop, slowly growing as the galaxy matured over cosmic time. J0107a's bar is not immature. It is not underdeveloped. The presence of not just stars but gas and dust in the bar suggests that it has been around for a good while, about 1 billion years. Sky and telescope a 1 billion-year-old bar structure in a galaxy that itself only formed 2.6 billion years after the Big Bang. That means this bar began forming when the universe was barely 1.5 billion years old. The team found that compared to modern galaxies, the concentrations of gas are several times higher, and the speed of the gas flow is faster, reaching several hundred kilometers per second. This is the first time these features have been observed, and they were not predicted by theoretical or simulation models. SciTech Daily. Not predicted. Not modeled. Not anticipated in any computer simulation of how the early universe works. A galaxy doing something no theory expected, at a time no theory allowed, with a structure no theory could produce. And it is perfectly calm. No scars of collision. No distortion. Just a beautiful, enormous, violently star-forming spiral sitting serenely in the chaos of the young cosmos. But J0107A is only one piece of this growing crisis. Because on May 16, 2025, the James Webb Space Telescope made the single most distant confirmed observation in human history, a discovery so unexpected that the research team named their survey Mirage or Miracle, because they could barely believe what they were seeing. Led by Dr. Rohan Naidu of the MIT Kavli Institute, the team confirmed the galaxy MOM Z14, a galaxy existing just 280 million years after the Big Bang, at a redshift of 14.44. The galaxy emitted light just 280 million years after the birth of the universe. After its long journey across the cosmos, that light is only now reaching Earth and Webb's infrared sensors. Live Science, the paper confirming this discovery, was published in the Open Journal of Astrophysics in January 2026, peer-reviewed and verified. This is not speculation. This is real. The broader story here is that JWST was not expected to find any galaxies this early in the history of the universe, at least not at this stage of the mission. There are, very roughly, over 100 more relatively bright galaxies in the very early universe than were expected based on pre-JWST observations. Space.com over 100 times more than predicted. Not 10% more. Not double. Over 100 times the expected number of bright galaxies at this extreme cosmic distance. As lead researcher Naidu stated, with Webb, we are able to see farther than humans ever have before, and it looks nothing like what we predicted. Which is both challenging and exciting. News the universe was not supposed to look like this. And it does anyway. Now here is where MOM Z14 stops being just a distance record and becomes something genuinely mind-breaking. Because when Naidu's team analyzed the galaxy's chemistry, studying the light from its stars and gas through Webb's NIRSpec spectrograph, they found something that has no business existing in a galaxy this young. Nitrogen. In extraordinary abundance. With MOM Z14 existing only 280 million years after the Big Bang, there was not enough time for generations of stars to produce such high amounts of nitrogen in the way that astronomers would expect. One theory the researchers note is that the dense environment of the early universe resulted in supermassive stars capable of producing more nitrogen than any stars observed in the local universe today. News, but the implications go even further. The nitrogen emission and highly supersolar nitrogen-to-carbon ratio hint at an abundance pattern similar to local globular clusters that may have once hosted luminous supermassive stars. Since this abundance pattern is also common among the most ancient stars born in the Milky Way, we may be directly witnessing the formation of such stars in dense clusters, connecting galaxy evolution across the entire sweep of cosmic time. AR-14 Think about what that means. The chemistry we see in the oldest stars in our own Milky Way galaxy today, stars that formed billions of years ago in the earliest epochs of our galaxy's history, may directly trace back to objects like MOM Z14. We are not just looking at the most distant galaxy ever found. We may be looking at one of the first factories that produced the building blocks of everything that came after, including, ultimately, us. And now, as if the galaxy crisis was not enough, a completely separate but equally devastating discovery has emerged from an entirely different instrument on the other side of the world. The Dark Energy Spectroscopic Instrument, DESI, sits at the Kitt Peak National Observatory in Arizona. Over 3 years, it mapped 15 million galaxies and quasars across 11 billion years of cosmic history to study the force that Albert Einstein called the cosmological constant, the energy of empty space itself that drives the universe's accelerating expansion. Einstein believed this force was unchanging, permanent, a fixed property of the fabric of the universe. And every cosmological model ever built has assumed the same thing. DESI researchers found subtle hints that dark energy has been slightly weakening with time.
This graph
Adam Rees, Nobel Prize winner, the physicist who co-discovered dark energy in 1998, stated, "If true, it would be the first real clue we have gotten about the nature of dark energy in 25 years." Quantum magazine in March 2025, DESI published its full analysis combining data from 15 million galaxies, supernovae, and the cosmic microwave background. Results suggest that the density of dark energy is slowly decreasing with time, data showing that dark energy is now 10% lower than it was 4.5 billion years ago. Wikipedia 10% less powerful than it was when Earth was young. If dark energy is not constant, if it is weakening, then Einstein's cosmological constant is wrong. And the standard model of cosmology, built on that constant for over a century, stands on a foundation that is quietly, measurably cracking. Stand back and look at what we are now dealing with, not one anomaly, not two, but a cascade of simultaneous crises across the entire field of cosmology. J0107a shows a galaxy that is impossibly mature and perfectly structured 11.1 billion years ago, defying every simulation of early galaxy formation. MOM Z14 shows a galaxy with advanced chemistry at 280 million years after the Big Bang, 182 times more luminous than any model predicted. The Hubble tension, confirmed by both Webb and Hubble, shows the universe expanding faster than the standard model allows, at a discrepancy now exceeding 6 sigma. And dark energy, the invisible engine behind it all, is now showing signs of weakening, threatening the mathematical foundation on which the entire edifice of modern cosmology has been built. Evolving dark energy would rewrite our picture of present-day reality. The most straightforward idea, that dark energy is the energy of the vacuum of space itself, should be an unchanging feature of quantum physics. Evolving dark energy would herald the presence of something extra, some previously undetected ingredient in the fundamental recipe of the cosmos. The missing part could be as simple as a new type of particle, or it could reveal a subtle failure of Einstein's theory of gravity. Quantum magazine: a subtle failure of Einstein's theory of gravity. These words, written by Quantum magazine citing DESI team members, are not the words of fringe theorists. They are the measured, careful language of the world's leading cosmologists describing what the data is forcing them to confront. The standard model of cosmology works beautifully up to a redshift of about 10. But beyond that, in the universe's very first moments, it begins to fail, and James Webb is the telescope that is exposing every crack. When the data stops fitting the theory, scientists do one of two things. They either find an error in the data, and Webb, DESI, Hubble, and ALMA have all been triple-checked, or they start considering theories they once dismissed as too radical. And right now, theories once confined to the margins of cosmology are receiving serious, peer-reviewed attention. One gaining significant academic traction is conformal cyclic cosmology, proposed by Sir Roger Penrose, one of the greatest mathematical physicists alive. According to this theory, our universe is just one in an infinite chain, each born from the death of the previous one in a cycle of cosmic rebirth. Penrose claims faint imprints of a previous universe may already be visible in the cosmic microwave background. The unexpectedly mature, structured galaxies Webb sees in the earliest epochs could, under this model, be remnants of structure inherited from a previous cosmic cycle rather than structures that formed entirely within our own universe's history. Another theory growing in mainstream consideration is the idea of primordial black holes. Black holes formed directly in the first moments after the Big Bang, which could have seeded early galaxies with the supermassive black holes we keep finding too early. And some researchers are now openly exploring whether Webb's observations hint at new physics beyond Einstein, new forces, new particles, new dimensions of reality that our current standard model of particle physics does not contain. The universe does not care what our models say. It simply is. And James Webb is the instrument that is finally showing us what it truly is. Every generation of scientists has believed they were close to understanding the universe.
After the Big Bang,
and every generation has discovered that they were looking at something far larger, far stranger, and far more magnificent than they imagined. Newton gave us gravity. Einstein gave us space-time. The Big Bang gave us a beginning. And now James Webb is giving us something we did not ask for but desperately need, the truth. The truth that a monster spiral galaxy 10 times the mass of the Milky Way was calmly building itself in the cosmic dawn. The truth that the most distant object ever confirmed by humanity contains chemistry that challenges everything we know about the first stars. The truth that the force driving the universe's expansion, Einstein's cosmological constant, may be weakening, changing the fate of everything that exists. These are not small adjustments. These are not minor corrections to the footnotes of textbooks. This is a revolution in human knowledge happening in real time, driven by a golden-mirrored machine orbiting 1.5 million kilometers from Earth. As the lead researcher of the MOM Z14 discovery said, JWST itself appears poised to drive a series of great expansions of the cosmic frontier. Previously unimaginable redshifts, approaching the era of the very first stars, no longer seem far away. Sigh, news if this universe, strange, shocking, and magnificent, fills you with wonder, then subscribe right now. Because this channel goes deeper every single week. And the universe is just getting